We need to find out the value of the given trigonometric expression. Let us begin. So what we'll do first is we'll try to find out the value of the individual ratios. Well, let's begin with cosine of 2 pi plus theta. Now 2 pi plus theta, we can express it as 4 times pi over 2 plus theta. What we have here is an even multiple of pi over 2. Whenever we have an even multiple of pi over 2, so cosine transforms to cosine only, so there is no change, but the new angle is going to be theta. Now we need to check in which quadrant 2 pi plus theta lies. Since we have written in terms of 4 pi plus 2, 4 plus theta, so we start from the first quadrant and we go in the anti-clockwise fashion. In the second quadrant we have 2 pi over 2, in the third quadrant we have 3 pi over 2, and in the fourth quadrant we have 4 pi over 2. So, but we are also adding theta to it. Theta is an acute angle lying between 0 and 90 degree, or 0 to pi over 2 radians. So that's going to take us to the first quadrant. Now in the first quadrant, all trigonometric ratios are positive. So that means we're going to get positive cosine theta. So cosine of 2 pi plus theta, it has the same value as cosine of theta. Now let's try out the second ratio. We have cosecant of 2 pi plus theta. And we can also rewrite it as cosecant of 4 times pi over 2 plus theta. Now 4 being an even number, so we have an even multiple of pi over 2. So cosecant is going to remain unchanged. So we're still going to get cosecant, but the new angle is going to be theta. Similarly, 4 pi over 2 plus theta is also going to lie in the first quadrant. All trig functions are positive. Coming to the third one, we have tangent of pi over 2 plus theta. So this is equivalent to tangent of 1 multiplied to pi over 2 plus theta. So 1 is an odd number. So here we have an odd multiple of pi over 2. So tangent must transform to cotangent function. That gives us cotangent of theta. Now 1 times pi over 2 means we are in the first quadrant, but we're adding theta to it, which is going to take us to the second quadrant. In the second quadrant, sine and cosecant are positive. Everything else is negative. Since we're working with a tangent function, our result should be negative in nature. So we should get negative cotangent of theta. Then we have cosine theta. We'll leave it as it is. Then come to cotangent of pi plus theta. So we have cotangent of pi plus theta, which can be also expressed as cotangent of 2 times pi over 2 plus theta. So 2 being an even number, so cotangent remains cotangent, so we're cotangent of theta. Now 2 times pi over 2 means we are in the second quadrant, but addition of theta takes us to the third quadrant. In the third quadrant, tangent and cotangent are positive. Since we're working with the cotangent function, so we will be getting a positive value. So we will have positive cotangent of theta. Now what we can do, we can finally replace all the trigonometric ratios with the simplified values in the original expression, so that we get, so we have cosine of 2 pi plus theta. So that gets replaced with cosine theta. Multiplied to cosecant of 2 pi plus theta. So that's simply cosecant of theta. Then we have tangent of pi over 2 plus theta. So this will be replaced with negative cotangent of theta. I missed one, secant of pi over 2 plus theta. So let me find it out as well. So secant of pi over 2 plus theta means which 1 times pi over 2 plus theta. So this will be equals to, since it's an odd multiple of pi over 2, so secant must change to cosecant. So we'll get cosecant of theta. 1 times pi over 2 means we're in the first quadrant, but addition of theta is going to take us to the second quadrant. Then the second quadrant, sine and cosecant are positive, but we're working with a secant function. Do not get confused with the final value. We're working with a secant value, and secant is negative in the second quadrant, so we should get negative cosecant of theta. We're going to divide by negative cosecant of theta, which is in place of secant of pi over 2 plus theta. Then we have cosine of theta. Then we come to cotangent of pi plus theta. So that came out as cotangent of theta. Fine. So let's cancel out some of the factor. So we have cosine of theta cancelling out. Cosecant of theta and cosecant of theta cancelling out, cotangent of theta. So all the factors got cancelled out, leaving us with -1 in the numerator and -1 in the denominator, which is finally giving us a value positive 1. So that means the value of the given trigonometric expression is positive 1.